Hello students, myself Dr. Mahantesh K, Associate Professor, Department of Electronics and Communication Engineering Department, SJB Institute of Technology, Bangalore. Welcome you to this pre-recorded video sessions on electromagnetic waves. So in this video, we are going to study what is the importance of electromagnetic waves. I'll introduce the subject in this video. Then we shall try to discuss about some prerequisites which are required to study this subject, and it is my privilege to teach you this subject, electromagnetic waves. In electromagnetic theory in undergraduate classes throughout the world for many decades, it has been changing. During the last decade, education on electromagnetic engineering has undergone a lot of changes due to the advent of many advanced computational and simulation tools. The focus of electromagnetics education, especially for engineers, has shifted towards the transmission line-based approach rather than more conventional field theory approach. The transmission line concepts are not limited to RF and microwave frequency range anymore, but they have also now become equally important to the field of high-speed digital circuits due to the requirement of carrying digital signals at very high data rates. Hence, students, it is now vital for any electrical engineering or electronics and communication engineering students to learn the basic concepts of electromagnetics and transmission lines, irrespective of whether you work in the microelectronics field or the computer industry. So as a teacher of electromagnetics, my experience with students has been like learning the concepts and easily implementing those concepts using theoretical concepts as well as number of solved examples on each topic, which will help students or create an opportunity to learn this subject in a better way. So I welcome you all to this pre-recorded video session on electromagnetic waves. So the syllabus of electromagnetic waves has been divided into 5 modules. In module 1, we will be discussing about Coulomb's law, electric field intensity and flux density. In module 2, we will be discussing about Gauss law and divergence, energy, potential and conductors in terms of point charge, line and surface charges and volume charges, different volume distributions, and the textbooks which is prescribed by V2 is Engineering Electromagnetics, William Hatt and John A. Buck from Tata McGrail Publications 2006 edition. The other 3 modules, module 3 will be discussing about derivations of Poisson's law and Laplace equation, followed by uniqueness theorem and some examples and solutions for Laplace equations. Also we'll study steady magnetic field consisting of Biot-Savart's law, ACL, that is Ampere circuit law, curl, Stokes theorem, magnetic flux and flux density, scalar and vector magnetic potentials. In module 4, we'll be discussing more about magnetic forces and magnetic materials, which includes force on a moving charge and its differential current, magnetization and permeability, along with the boundary conditions and magnetic circuit with potential energy and forces on magnetic materials will be dealt in module 4. In module 5, it will be a completely transition from static electric field and magnetic field. Now it becomes a time varying fields and followed by Maxwell's equation. Maxwell's will say what happens with respect to a time varying field, what is the force, how it enacts in varying magnetic field. So Maxwell's equations in point form and integral form will be explained in this module 5, followed by uniform planar waves. wave propagation in free space, and good conductors, Poynting theorem, which gives more importance on power dissipation or power calculation in any electromagnetic wave, and wave power, skin effect. So these are my complete structure of your syllabus scheme and syllabus with respect to your electromagnetic waves. The question paper pattern is quite conventional. The question paper will have 10 questions. Each full question carries 20 marks, and you'll be allowed to write 2 full questions with each part or each module, which consists of 20 marks. Put together, you will get 100, and that 100 marks will be reduced to 60, scaled down to 60 as an semester end examination. And for your internals, it will be evaluated for 40 marks, in which 30 marks will be kept for your internal assessment. The remaining 10 marks will be kept for your assignment submissions. So as I've told, there are different textbooks and reference books. Engineering Electromagnetics, the first one which you could see on this table is the prescribed textbook for studying electromagnetic waves as per the VTU syllabus. The other 4 textbooks are reference book, Elements of Electromagnetics, Electromagnetic Waves and Radiating Systems, which combines microwaves and radar concepts for studying electromagnetic waves, and the very basic subject, very basic concepts in electromagnetics by Joseph Edminster, Shom series, Fundamentals of Electromagnetics for Engineering, N. Narayan Rao, Pearson Education, publication. So that is, again, it's quite a basic textbook where it would be a revision of your +2 physics. So coming to the vector analysis. So this is just a preamble for your studying of electromagnetic waves. So what is vector analysis? It is a mathematical subject which is much better taught by mathematicians, but we here are trying to brush up some concepts on vector analysis. Okay, so what do you mean by vector analysis? Here, vector analysis is a mathematical shorthand. It has some new symbols and some new rules and a pitfall. So here and there, like most new fields, and it demands concentration, attention, and practices. Okay, since we are trying to evaluate the field, I say electromagnetic field. Field consists of like a quantifying a point. If you are trying to measure a point in terms of its magnitude and direction, so field is nothing but it's a measure of a point with respect to its environment. So it requires a 3-dimensional analysis or 3-dimensional coordinate system. So 3-dimensional coordinate system can be better analyzed using vectors. So that is why vector analysis is very much important for us to study or to have a preamble or a prerequisite in order to deal with electromagnetic waves in detail. So what is electromagnetics? As I said, electromagnetics is a combination of electric field produced by the presence of electrically charged particles and gives rise to the electric force. And the other combination is magnetic field produced by the motion of electric charges or electric current that gives rise to the magnetic force associated with magnets. Now you could see here, electric field and magnetic field combined together, which produces electromagnetic waves. If you could carefully observe here, purple lines as well as the gray line, which is electromagnetic waves, electric field and magnetic field, which are perpendicular to each other, and the propagation of these electromagnetic waves happens to be in perpendicular direction. If you see, look at this corner of this image, you can see they identify the peak with respect to the top peak and with respect to the peak which is slanted. So these are perpendicular to each other, and the propagation happens to be in the perpendicular direction of both the fields. So electromagnetic wave, so as I mentioned, electric wave or magnetic wave, electric field or magnetic field are perpendicular to each other, and the direction of movement is again perpendicular to both of the planes. So why do we learn engineering electromagnetics? Excuse me. Electric and magnetic field exist nearly everywhere. So as you could see here, electromagnetic waves with a larger spectrum of electromagnetic wave spectrum, it can be seen in this image, like it varies from 10 to the power of 3 to 10 to the power of minus 12, the longest wavelength till the shortest wavelength. And you could also see the radio waves are varying from 10 to the power of minus 1 to 10 to the power of 3. And microwaves ranges from 10 to the power of minus 1 to 10 to the power of minus 4. whereas infrared waves ranges from 10 to the power of -3 roughly to 10 to the power of -6. So as and when you could see some of the wavelengths and its application, the soccer field can be identified with respect to 10 to the power of 2, whereas house 10 to the power of 1, baseball 10 to the power of -1, the wavelength. And this period, some time instance, the cell, bacteria, virus, protein, water molecule, as and when it's getting decreased, the shorter the wavelength, the shorter the particles. Okay, and you can also see ultraviolet rays and hard X-rays concentrated towards the band of frequency of wavelength 10 to the power of -10 to 10 to the power of -12, and the gamma rays, of course, from 10 to the power of -11 to 10 to the power of -12. So also you could see that the last but one column here, the sources in order to generate this wavelength electromagnetic waves are AM radio, antenna, RF cavity, FM radio, microwave oven, radars, of course this cell, bacteria and all these things are people, viruses from light bulb and other machines or the other equipment. So also you can see frequency waves per second in terms of hertz, and also the energy in terms of electron volts with respect to the different electromagnetic spectrum. Coming to the applications, so we have wide variety of applications in various disciplines such as microwaves, X-rays, antennas, electric machines, plasmas, and etc. You could see here some of the examples with respect to the plasma and antennas and X-rays, and then other electric machines, detection of objects or detection of equipments if it is hidden, and so on. In continuation with the application, electromagnetic fields are also used in induction heaters or for melting, forging, annealing, surface hardening, and soldering operations. Electromagnetic devices includes transformers. You might have studied in your basic physics, induction transformation and transformer EMF, induction EMF, and so on. So it includes transformers, radio, television, mobile phones, radars, lasers, etc. Continuing with applications, you could see the trans rapid train, which operates on a magnetic traveling field, moves without the contact of the vehicle. Okay, you could see here. So this guides magnetic control propulsion, so it generates enormous amount of force, okay, a friction between a train and a rail. So the speed can be continuously regulated by varying the frequency of the alternating current, which in turn generates the large amount of electromagnetic force which push the train onto the rails. Thank you guys. I hope you have enjoyed watching this video on basics of electromagnetic waves, syllabus and its applications. Thank you for watching this video again. In the next video, we'll be discussing more about vector analysis and the different aspects of coordinate systems. As I mentioned earlier, that we are trying to quantify the elements of the point on a field. So it needs to be measured. So you need to have a metric or a coordinate system which will be used to compute the magnitude as well as directions of the field. Thank you. Thank you for watching this video. Take care.